Okay, hey there, we're going to talk about exercise 6C and 6D. A couple of questions to think about. First one says that, what's the odds when we get two cards dealt to us from a standard 52 card deck that we're dealt blackjack, which means that one card is an ace. It could be any of the four aces, spades, hearts, clubs, diamonds. And the other one is a king or a queen or a jack or a 10, and can be any of those four suits. So what's those odds? Number two, what are the odds when we get five cards dealt to us from a 52 card deck that we get a royal flush? Which as you can see from the picture is ace, king, queen, jack, 10. The order doesn't matter, but the suits must all be the same, i.e. hearts or spades or clubs or diamonds. Have a think about those two questions. Hopefully you've got your CAS handy. We're just going to think about if we have three students, A, B, and C. We want to arrange two of them in a row. How many different permutations are there? So over here, we've got three people that could be in the first spot. That leaves two people that could be in the second spot. That means that there are six possibilities for if we have three students. How can we arrange two of them in a row? As it says over here, their order in the row will matter, okay? And we know there are 3 times 2 ways of doing this. So there's 6 ways, which is what we saw before. Over here are the combinations, A, B, A, C, B, A, B, C, C, A, C, B. We can use our CAS to find 3, P2. If I look at TI, menu probability permutations, 3, P2, we get 6. If we look at ClassPad, we come down here to advanced NPR 3, choose 2, we get 6. Use our CAS to confirm the answer. Make sure that you're happy with that. Now let's say we have 3 students and we want to select 2 of them to help in the canteen. In this case, the order doesn't matter, because if we choose A and then B, or if we choose B and then A, the result is the same. We're going to have 2 people to help in the canteen. Here are the possibilities. We can choose A and B, A and C, or B and C. In our CAS, we're going to write this as 3, choose 2. Now, it's in the same location, probability combinations, or you can just type it in CR 3, choose 2, and we get 3. Same on ClassPad. I'm right here, so NCR 3, choose 2, and we get 3. So how many ways could I choose 5 cards from a standard pack of 52 cards? And we're going to say that in this case the order doesn't matter. So if I'm going to choose 5 cards, that's going to be, out of 52 cards, give me 5. Not 2, sorry, give me 5. That's about 2.6 million ways. And so question 4 says, what's the odds that the 5 cards that you choose form a royal flush, which is ace, king, queen, jack, 10 of the same suit. So from before, there's actually 4 combinations of ace, king, queen, jack, 10 of the same suit, because there's 4 suits. Spades, hearts, clubs, diamonds. So in fact our answer is going to be 4 combinations out of all of the combinations. And so that means that your odds of getting a royal flush, if you get dealt 5 cards, is about 1 in 649,000. What is exactly 1 in 649,000? 740. So pretty low odds. So taking a look at our handout, we're going to fill this in 10C, 10D, combinations and applications. In this case, we're talking about where the order doesn't matter, as opposed to permutations where we might be arranging items in a row and the order would matter. So filling in this box here, finding the number of combinations of n objects. Okay, so I've got n objects in groups of size r. We can write this as n choose r. For example, 52, choose 5. This is also commonly written as n choose r using round brackets, and it's generally how I prefer to write it. And the formula for this, which we do need to know, is n factorial on top. On the bottom we've got, on the bottom we've got r factorial, n take r factorial in brackets. Looks kind of complicated, but once we begin to use it, we'll see it's not too bad at all. Now this second formula here, we're going to revisit in a moment. So to begin with, the first example says how many groups of 2 people can be selected from 3 students to help in the canteen. We did that before. We saw the answer was 3. In terms of what I would write here, I would say that we've got 3. And we want to choose 2. If I was to use the formula, on top we have 3 factorial. On the bottom we have 2 factorial. And we've got to do n take r factorial, which is 3 minus 2 factorial, which is just 1 factorial. Now 3 factorial is 3 times 2 times 1 on top, and 2 factorial is going to be 2 times 1, and 1 factorial is just 1. And so we can see that our answer is 3. Now, in cases like this, for example, if it was 10 choose 9, our answer would be 9. If it was, our answer would be 10. If it was like 8 choose 7, our answer would be 7. And when it's 3 choose 2, our answer is 3. And that's just going to be a general rule we can remember. Down here, in how many ways can a group of 5 be selected from 8 dogs and 4 cats without restriction? So we've got 12 animals in total. So we'll write that here, 12. And we're going to choose 5. This is take active, so we'll put this into our CAS. Let's see what we get. 12, choose 5, 792. That's a different number. That's the number of total combinations that we can choose 5 animals from the 12 available animals. Part B says if there must be 3 dogs in the group. So that's a restriction. So let's think about this and how many ways can we do this? There must be 3 dogs. So let's look at the dogs, of which there are 8 dogs. We must choose 3 of these dogs. Now let's look at the cats, of which there are 4 cats. Because we need 5 animals in total, and we chose 3 dogs, that means that we must choose 2 cats. And this is kind of the method we can use for these types of questions. And so we can, this is take active, but let's just see what would happen. We've got 8 factorial on 3 factorial, and then n take r factorial, which is 8 take 3, so 5 factorial. And I'm just doing this because I just want to show you that while the formula looks a bit tricky, it's actually quite nice to use. And then this is going to be multiplied by, on top we've got 4 factorial, on the bottom we've got 2 factorial, and then we've got 4 take 2 factorial, which is also 2 factorial. Now this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is 5 times 4 times 3 times 2 times 1. Kind of like up here where the 2 by 1 over the 2 by 1 cancels. So if I just look at a factorial over 5 factorial, that's just going to be 8 times 7 times 6, and then all the rest will cancel. And on the bottom, I've got 3 factorial, which is 3 times 2 times 1, which is 6. And then this is multiplied by, so 4 factorial over 2 factorial is just 4 times 3. And then we've still got another 2 factorial on the bottom. Okay, from here, do some cancelling. Let's put the 2 into here. So I'm left with 56 times 6, which is 336. Now this is take active, so let me just double check. I've got NCR E choose 3 times NCR 4 choose 2. Yes, 336, great. Okay, so moving along, 3 nominated students are given the opportunity to represent the school at a maths day. The team may consist of 0, 1, 2 or 3 members. How many different members could there be? We could list that out. Let's pretend our students are A, B and C. So we could, first of all, we could choose everybody. We could choose 2 people. So AB, AC, BC. We could choose 1 person, ABC. We could choose nobody. And so I can see that there's 8 possibilities there. That's how many different teams we could choose. But coming back to the top here, finding the number of combinations where 0 to n objects are chosen. In this case, 0 to 3 objects are chosen. We can simply use 2 to the power of n. And in this case, we're choosing 0 to 3 objects. So the shortcut for this would be 2 to the power of 3 is 8. And so that's going to give us the same answer as if we counted all the possibilities. Okay, so let's look at this last one. This last one says that a debating team of 6 people is to be formed from a group consisting of 5 year 10s and 6 year 11s. So 11 people in total. If a team is to be selected at random, what is the probability there will be, well, there will be exactly 3 year 11s. So I've got to think about, I'm choosing 6 people. So if there's 3 year 11s, there's 3 year 10s. Now there's 5 year 10s, and we're going to choose 3 of them. Now consider the year 11s, for which there are 6 year 11s, and we're going to also choose 3 of those people. And then the total number of possibilities is, out of these 11 people, we're going to choose 6. And this is going to give us our probability. Definitely going to be over here. NCR 5 choose 3, NCR 6 choose 3 over NCR 11 choose 6, 100 over 231. Okay, there will be at least 1 year 10, so there could be 1 year 10 or 2 or 3 or 4 or 5, and that's a lot of combinations to add up. But of course, I'm always going to try and use a complement where it can speed it up. So this is going to be 1 minus the complement of at least 1 year 10 would be 0 year 10s. And so the probability of 0 year 10s would be that out of 5 year 10s, we choose 0. And out of 6 year 11s, we choose all of them. And this is going to be all divided by 11 choose 6. Now before I put this in my calculator, 5 choose 0. So if I have 5 people and I want to choose none of them, there's one way I can do that. I choose none of them. There's one way. If I have 6 people and I want to choose 6 of them, I have to choose all of them, and that's the only way I can do that. So again, this is 1, so 1 times 1 on top is just going to be 1. Go to the CAS, 1 subtract, on top is 1, and the bottom is 11, choose 6. 461 on 462. Okay, and the last question, we can have at least 5 year 11s. So we've got 6 year 11s, so we can have either 5 or 6. And there's 2 possibilities, and there is no, I just have to count them. So let's say if I have 5 year 11s, that means that out of the year 10s, I'm going to choose 1 of them. And out of the year 11s, out of the 6 year 11s, I will choose 5 of them. And that's over 11 choose 6. And then additionally, I could have 6 year 11s. So out of the year 10s, out of the 5 year 10s, we don't choose any of them. Out of the year 11s, we choose all of them. And that's out of the total possibility, which is 11 choose 6. And this is very similar to what we did before. In fact, this is going to be 1 over 462. So we're just going to figure out this one. Now while I'm here, if I have 5 people and I want to choose 1 of them, there's 5 different people. So this is just 5. And if I have 6 people and I want to choose 5 of them, there's 6 different ways I could do that. So on top here, we've actually just got 5 times 6. This is going to be 30. And then this is going to be 1. So in fact, our answer is going to be 31 over 462. But we've got a CAS, so why not check? Okay. NCR, 5 choose 1. NCR, 6 choose 5. NCR, 11 choose 6. Plus okay, 5 choose 0, 6 choose 6, 11 choose 6, 31 over 4, 62. And so coming back to our original question of what's the odds that when 2 cards from the standard 52 card deck are given to you, what's the odds that you get blackjack? 1 card's an ace, the other one is a king, queen, jack or 10. We've got a couple of possibilities. For example, we could think of it as well, let's do combinations, right? We've got the first card is an think of the aces, of which there's 4 of them. We've got to get 1 of them, and then we think of what we call the picture cards and the 10, so king, queen, jack or 10. There's 16 of them, and we have to get 1 of those. And out of the 52 cards, we're dealt 2. So the probability of blackjack is, around about 5%. That's using combinations. If we did it the longer way, we could think of it as, let's say if our first card is an ace, so out of the 52 cards that there are, there's 4 aces, and then the next card that we are dealt, because 1 ace has been, it's not replaced, there's 51 cards, and we need to get 1 of the remaining picture cards, or the 10, so there's 16 of those. Okay, so this is saying that first I get an ace, and then I get a picture card, but we could also have it the other way around. So if we were to get the picture card first, there's 16 out of the 52, and then we could get the ace the other way. So out of the 4 aces, we need 1 of those for the remaining 51. And notice that these are actually the same, because on top I've got 4 times 16, on here I've got 4 times 16, on the bottom I've got 51 times 52 on both occasions. So in fact I could just multiply this by 2 and we get the same result.